All right, so let's see, what does this problem say? Following vigorous exercise, the body temperature of an 80 kg person is 40 degrees Celsius. So on the Celsius scale, your body temperature is 37 degrees. And so this is roughly a 10% rise in your body temperature. 3 degrees Celsius rise is in Fahrenheit scale, that's a rise by 6 degree Fahrenheit. And if I would imagine if you had a fever like that for a day or two, I mean, it can be fatal. So what does your cooling system have to do? It has got to cool your body down real fast. Okay. So at what rate in watts must the person transfer thermal energy to reduce the body temperature to 37 degrees in 30 minutes? Okay, so your cooling system has 30 minutes to cool you down. Okay. Assuming the body continues to produce energy at the rate of 150 watts. So now you have to get rid of this, you got to cool down your body, okay, by 3 degrees Celsius, but also at the same time, in the 30 minutes, your body is functioning and it's producing 150 joules of heat per second. So you have to get rid of that as well. Okay. So the normal rate you have to maintain. So right now Ben is, let's say his body is getting rid of 150 joules per second at normal temperature. Now, if he was hot, you have to get rid of that extra heat. Okay, so that's what they're saying. All right. So let's see, 80 kgs. Okay, so let's figure out how much heat would you have to reduce. Specific heat. Oh, okay. Okay, assuming the body continues to. Okay, the problem doesn't say this. Essentially, what you have to assume is. What you have to assume is we are just a bag of water. So you're cooling down a bag of water from 40 degrees. Okay. Okay, so this much heat is what you have to remove to cool it from 40 to 37 degrees Celsius. Okay, the specific heat of water is 4,186 joules per kg per degree Celsius. The mass is 80 kgs, and the temperature is 37 degrees is the final temperature, 40 degrees is the initial temperature. Okay, so Q will come out negative, telling you that's how much heat you have to remove from the person. Okay. Okay, so you have to remove 1,000,000 joules of heat. Yep. The change is C times M times T final. Change in anything is that. Yep. All right, so okay, so the power is, and now we'll just do absolute value. Power is the rate at which you have to remove heat is heat removal 10 to the 6 joules times 30 minutes. 30 minutes is that many seconds, plus the 150 watts that you have to do for this is the normal cooling. Okay, on top of that. Yeah. So normal cooling. This is excess heat removal. Okay, so this works out too. All right, so your body is pretty impressive. So here's what this number means. If you're just sitting down here, your cooling system is working at a power rating of 150 watts. Then you went and exercised, and suddenly you had to increase by 600 watts, essentially. So now by a factor, you have to increase by a factor of 400%. So imagine your home air conditioning, which is a, I don't know, 2-ton air conditioner. That's its normal function, and a few people came to your house for a party, and suddenly it has to work as a 10-ton air conditioner. That's what that means. Yep. So we were calculating the absolute value of the power. Yep.
When you take the 6 divided by 30 times 60,
Mm-hmm.
is that in watts, or did you convert it to
Yeah.
watts?
Joules per second is a watt. Yep. So again, just shows your body is pretty impressive. It can do a whole bunch of things